Welcome to the Builders and Makers series, where we explore the exciting work of our technical experts, who they are, what they're up to, and how they're inspiring innovation. Each episode, you'll get an inside look on how members of our team bring value and push the envelope for our clients. Let's meet our next builder and maker.
I'm a cloud architect, so my job is to oversee architecture, implementation, everything from beginning to end of entire projects at clients. So one of my most proud projects is actually one of my most recent projects, where I was asked to move 13 terabytes of data out of this old legacy Documentum system that I actually helped this same client put in about 7 years ago. So the client was very interested in getting this project done for a few reasons. First of all, Documentum is a 7-figure annual license that's very restrictive. They wanted to get rid of that cost, and hard to maintain because it got sold 2 or 3 times to different companies, and now you can't even find people who work on it. They needed to get off of that. And then it got worse when they realized that they have to get off their production data center by July. The lease of the building company sold it, they lost their lease, and they said, you guys have 9 months to get out. But it was really complicated because it was 13 terabytes of binary files, 16 million records in a database that was proprietary, that was abstracted, and we had to get all of that moved to a brand new metadata format, brand new file system, put an S3 up in the cloud, and no one yet had to figure out how to solve this problem. They didn't know where to start. So the innovation required on this project had to do with the nature of the source data. So when you're talking data migrations in Amazon, a lot of people immediately go to things like Snowball, where you literally copy your file, you take a box and you plug it into your network and you copy all your files, you literally put it in the mail and FedEx it to Amazon and they import all that data for you. When you're talking that much data, that's typically what people think you should do. The problem is with the Documentum data, we could not use one of those snowballs. They wanted to do a date range, like they only wanted half of it going back about 7 years. But the way Documentum stores its files, it kind of has a hashing algorithm that partitions it all out. There's no subfolders you can target, and it doesn't support date ranges. So we were stuck. We had to write something custom to do it ourselves. So not only that, but we had to do a metadata translation from the database to the server. So we couldn't just copy the files and we're done. No, it's every file had to have a database record pulled and sent with it, shoved into a new format. And that was the real trick. To do that, and with the final wrinkle is the one move wasn't finished, people are still using the old system, so they had to continue to siphon old data and keep replicating until they turn it off sometime in July. So finally, we had to do this in such a way that did not take out the production servers in the middle of people using them. This project was a series of prototypes that had to build on top of each other. It's like we had an idea. There were 10 ways we could have sliced this. I worked with some of the other developers to brainstorm an approach. But it became of, well, in order for this to work, we have to first try this, and then we have to try this, and then we have to try this, and we have to try this. And each one of those started to build on top of each other. So, for example, we had to come up with some kind of queuing mechanism by which we could grab records 1,000 at a time, send them to the cloud, let them migrate in parallel. Ultimately, we figured out a way to update the legacy system with some heavy-duty indexing and employ a DBA. And the next problem, right, is we can queue the data over in a short time frame. Now we got to figure out how to process it all in parallel. So all the records get sent over, and then each one has to call back into the system to say, give me your data, give me your files, and then put it all where it goes. So it was a matter of a single data pipe and then kind of fanning it out so we could actually process it in a time frame that wasn't 9 months. That was the initial estimates that we had. We also had to process it at a scale, like I said earlier, that won't take out the source system. So we couldn't just let Amazon rip at full bore and spin up as many functions as it wants because it would kill the server. We tried. We had to find that tipping point. We wanted to know what we were dealing with. This had 4 or 5 layers in between, so we had to tune scaling at each layer to get this fully optimized. Like the database was how many records at a time, how many do we shove into SQS at a time, how many lambdas can run concurrently. There's an API layer in between that was clustered. In EC2, how many of those can we run at the same time without taking the server out? We also had to make it idempotent, meaning you could rerun the same files over and over and it wouldn't create duplicates. So we were going to need to make sure that if you send this through, you're only going to get one result on the output, no matter how many times you send it through. So I think what I'm most proud of for this solution is the fact that it was entirely, for the most part, serverless architecture. So we are able to do 13 terabytes of data, 16 million records. The whole process took under 2 weeks and cost about $7,500 of AWS infrastructure, which I thought was pretty impressive, considering how much we had to move, and the solution we built just sipped resources. This project is one of the largest scale type projects with data that I've ever done. So I got to learn a lot about how SQS works with Lambda at scale. I got a lot of experience using the event bridge. We got to play with all kinds of cool tech that was the right tools for the job at scale to perform a big time data migration. That easily translates to things we do here at CleanSlate, especially with our migration competency specialty that we have with AWS.